Welcome to Made Up of Wires. We are decompiling Castlevania Symphony of the Night. We've been doing that for a couple weeks now, and we're going to continue. If you want to know more about decompiling Castlevania Symphony of the Night, you can go to SOTN.z.dev, where you will find status for the project. This isn't my project. This project was started by Zianimo a couple years ago. I found it about 4 or 5 months ago. And started contributing and thought it would be fun to stream some of these decompilations for educational purposes and to kind of time box myself as well and give myself a nice little period to spend each day doing some decompilation. I think we're going to look at this last Maria function for the clock room today. We'll try to get through it. I'm not sure if we'll quite get through the whole thing yet, but hopefully we'll get pretty close. On SOTN.z.dev, you can see progress that we've made on several of the overlays that exist on the PlayStation version of the game, and more of those will be coming. There are many more than we currently are working on, but what has happened with this Maria overlay that got brought in over the weekend, it turned out that about 95% of the code in the overlay was duplicated from things that we've already decompiled. So we were able to basically only have a handful of functions, new functions that needed to be decompiled, and so I'm hoping that other overlays go as easily. We do need to look at what those look like in different versions of the game as well, and if you've been on the stream before, you've seen that the PSP version is certainly helpful when decompiling, and so we're looking at PlayStation and PSP versions. In the future, we might spend some time on the Saturn version as well. So what is decompiling? I used to give this spiel at the beginning of each stream, and I kind of got away from it when rushing through the weapons. You'll see my weapon counter is gone because I'm not going to focus on weapons probably for the next couple streams. But hopefully we'll get back to that eventually and get that finished off. So when we decompile, we're taking code that was on the game disk, or files that were on the game disk, extracting different parts of those, some of which are sprites, audio, other things like that, and what we're interested primarily here is the code. That gives us machine code, and I mentioned this in the last 2 streams, I think. When I was in college many years ago, my computer architecture course just happened to be studying and re-implementing MIPS processors, and here's my textbook from I think this is the second version of Computer Organization and Design from 1998. It was written by one of the founders of the MIPS Corporation, who designed the MIPS processor, and that book is a treasure trove of MIPS information. I dug it out of my it turned out to be in a closet. I thought it was in the garage. It turned out to be in a closet. And yeah, dig down deep. That's right. You look at all the bits, and there she is. So I decided to find this and just see if it was what I remembered it to be, and it actually, I think, is quite a bit more. When I started decompiling on this, I hadn't done any PlayStation decompiling prior. And so I was refamiliarizing myself with MIPS assembly, and compared to, I feel like there's a lot of really good resources that I found previously for Motorola 68K assembly. But what I was finding for MIPS was less good. And I'm not sure why that is. What I want to point out, so when we're disassembling, we're taking machine code that's encoded in binary, and then we're using some tools to convert that binary back to assembly language, and then what we're working on is writing then C code for the assembly language. I've used that sequence several times in the past, and if I can get OBS to cooperate, I'll load these images. As I was going through one of the appendixes in this book, basically it follows the same thought process. Let's load these up here. So here's its example of machine code encoded as binary. And then it helpfully provides the assembly language for this as well, and kind of goes through the same general idea. Machine code is nearly, as a human, you could train yourself to read it, but it's not going to be something that you really want to spend a lot of time on. So here's the assembly translation, and you can do this with a machine. Programs we're using Splat64, which will do this for you. And then what we want to get to, obviously, and what we're going to be working on today is let's load it up here, is the C code. And when you see the C code, you're like, oh yeah, that's much easier to read. So this is a pretty simple function that just prints 1 to 100. And so this is the process that we're going through. Fun to see it in the book. I recommend that book. I know people probably don't read books. Yeah, I mean, I sit down with a glass of whiskey at night, print out some code listings, and that's what I do before bed. I don't print them. That's the only difference between reality. Okay, so let's kind of get back to Castlevania. Why Castlevania? Because it's a fun game. I like it. I found it much too late in life, but have been. I'm not like a huge super fan. I do think it is one of the greatest games ever made, and it introduced me to like the whole Metroidvania. NES Metroid. This is probably sacrilege to a lot of people. I just never could get into NES Metroid. The aesthetic, the lack of any like tangible progress. Every time I played it, just never got into it. For whatever reason, Symphony of the Night almost immediately just worked and got me into just the whole Metroidvania genre. I think one of the next ones I played was Shantae's Half Genie Hero, which is awesome. Rabby Ribby, if you've played that, that's a lot of fun as well. I enjoyed. There's some people that are very critical of it, but Deedlit in Wonder Labyrinth, I think, is a great Metroidvania as well. I did like Metroid Dread. I thought that was really good too, and maybe I'll go back one day and play Super Metroid. Maybe it's better than NES Metroid. All right, so this is the progress we have so far. As I mentioned, Sozu had done a lot of work to bring in the Maria clockroom cutscene, and that's really far. We worked on one of the methods, or one of the functions in that yesterday, and I think, the main Maria cutscene function is large, but I think we'll give it a shot and see what we can do there and if we can make any progress. So we're going to be using decomp.me, which is a collaborative code editor that will give us a comparison between the original assembly and the assembly that we're generating with our C code. I'm going to flip over to my terminal and find what we have next. There was one thing that might, if you were on the stream yesterday, that I could point out as well. We had a somewhat unique control structure. Where we were basically trying to find, determine whether or not the player position or the entity position was within kind of a certain area. And we'll look at what the decompiler did, M2C. So we had this here where we were taking the entity position, shifting it by, that's around 120 or so, to the left, and then doing some shifts, comparing the value, is it less than 0 or not, and then doing some more work here. This actually turned out to be much simpler, and what I probably wouldn't have looked into it any deeper, but I decided to load up the PSP version just to see how close the match was. And this section compiled relatively similarly on the PSP, but the shift by 4 made me think of, so a shift by 4 bits is the same as an integer division by 16 typically. So what if this was an integer division by 16 and it turned out that that's what it was? So the decompiler didn't figure that out and kind of built this whole structure here, and it turned out to just be a relatively simple integer division. I'm pretty sure that I have Cave Story, and I probably should play it. I don't know why I've not looked at Cave Story. There's a few others too, like Hollow Knight. I didn't get into. I felt like progression there was slower than I want it to be. The Metroidvanias I like. It feels like you're always discovering a place that you can't go, and then shortly after, not discovering how to get to that place, but maybe get to a place that you saw 4 or 5 areas ago, but almost constantly either kind of having to note things that you can't do yet, but you know you will be able to do, or are gaining some type of new ability that's going to allow you to go to those places. And I felt like Hollow Knight, which again, that's a very beloved game, a lot of exploration, and I just didn't feel like I was ever gaining those abilities that are kind of what I enjoy about the genre. So we're going to look at Entity Maria cutscene. I have not looked at this yet. There are so this function name is used in other overlays as well, for when Maria is doing those other things. And so we'll open this. There's not much interesting in the C file at the moment, because it's mostly just pulling in other cutscene common functions. But what we want is to try to get this main cutscene finished, and then based on the how the compiler brings in RO data and some other things like that, it should actually help us. Yesterday we had to split a file to get RO data to go in the right place. This should help us get those things back together so the ordering is correct. Off screen, I am copying this into decomp.me. Go over there. So we're going to look at the PlayStation. We might load up the PSP version as well. And I don't remember if I fixed my context. We definitely have things that are not yet in the context for the decompiler, so we'll have to fix those as well. This one, I might change the name to make it easier to find. I don't think we have a pattern yet for naming these. The issue is there are several Entity Maria cutscene functions, and so we want ours to reflect that we're specifically looking at this clockroom version of it. Let's see if there's anything that we need to know before we continue. So several cutscene related functions, we'll pull those in, the definitions for them. It is a big function. We'll see whether or not it ends up being a complicated function. It's possible that this looks a lot like the main weapon driving functions, and we can look at some of the other Entity Maria cutscene functions as well, and determine whether or not those are relevant. So first we need to get a bunch of these declarations, and I'm going to go back and find where those are, or what they are. Many of these are pulled in because they are common. The way that overlays are built, they share a lot of similar code. And so a lot of that has been abstracted out into common functions. And so we just want to grab the declarations for each one of those, and then we'll run the decompiler again so that it can try to figure out more local variables. This will take a little bit of work, but it'll get us a better starting point. I've been getting a bunch of comments on YouTube, and one of the comments, and I apologize because I haven't checked it earlier, but was about how terrible the audio was, and so I've added a filter, and if the audio is sounding better, let me know. If it's sounding worse, let me know. Is the context evolving over time? What I've found in general is yes, it's difficult to say. I like having a context that's most specific to the area that I'm working on. So weapons have a very different set of declarations for functions than stages. You can just keep building up a context and adding a bunch of these things, but occasionally you'll get a declaration that is that conflicts between the two, and that's primarily because potentially the function is being called without a declaration in one case versus with a declaration in the other case. I think most people, just kind of build up their context though over time, and typically that works. The way that the header files are configured in the project, you're mostly bringing in just about everything anyway. If I sound good on crappy speakers, I must sound awesome on awesome speakers. I doubt that, but let's see, where are we looking? Oh, okay, so we don't have this signature yet. So we're gonna have to figure out what this one is. And it looks like the decompiler has a guess. Let's see if the return value is being used. It's not, so I'm gonna assume that it's a void. That may change whether argument registers are used for temporary variables or not. And I'm guessing this one is also not defined yet. Oops. So let's see how this one is being used. So we're taking in a value. We can peek at the assembly for this one. This actually, it's possible that this is a dupe. Let's look that up. So I do have duplicates open. It is a duplicate. And the others have been decompiled, so we can find the signature for one of those other ones. So it's taking an unsigned 8. Otherwise it's void. Yeah, the first streams were definitely terrible. So I have, it's a fine microphone, not anything terribly special. And my, it is a XLR mic going into an audio interface. That audio interface doesn't seem to provide enough gain for the microphone, and I'm not sure why. So I have gain boosted in OBS significantly, and then that ends up adding a lot of noise. It looks like I missed. Oh no, I duplicated that one. So I'm going to put those back into the context, and we'll see if what we can get from that. Oh, my context is still broken. I have my PSP. No, I don't. We have a syntax error. I'm missing a semicolon. There we go. That's much better. So cutscene unknown 4 I missed. And that one's void. So one thing that I didn't know until working on this project, I've been doing C for close to 25 years. And maybe this is like super obvious to everybody, but it just never occurred to me. When there is void in the parameter list, that means the function takes no arguments. That is not equivalent to not having arguments in the function list. When there are no arguments in the function list, the function may take an arbitrary number of arguments. It's unspecified. Maybe everybody knew that but me. I wasn't at the meeting when that was decided, apparently. All right, so now we have several variables that we don't have types for yet. Some of these, I'm going to refer back to the work from yesterday. These may also be animation indexes. Let's go down here first and see. So they are arrays. Let's follow this variable around. So ultimately, they're coming back to this particular variable here. My guess is that this is a primitive. It's either a primitive or an entity. And we need to figure out why the decompiler didn't resolve this. Once we understand this type, we should be able to figure out what some of those variables are. So it's coming from unknown to C in temp S1, and we're going to have to figure out what that type is. And so that is coming from, it's a pointer to this offset. So something that's let's go look at that. That looks like a pointer array. These are all 4-byte offsets. So maybe we're not going to learn anything from this code, but we might learn something from the data. Okay, so these are uninitialized. I'm going to go look at what Splat decided the sizes of these were. It's treating them as bytes. Let's see if we have... not entirely convinced that that's the case. Let's actually look at the other entity Maria cutscene functions, and if we can get a sense of what that structure is, that'll help the decompile a lot of those fields. And if we don't have to map those fields manually, that would be helpful. So I'm going to find the path of that, and then we'll look at it in GitHub, because that's probably a little nicer. So NZ0 has one implementation of a Maria cutscene. So this is a stage, and we're going to look at NZ0. I forget what NZ0 is. And this is going to be in Maria cutscene, creatively named. So we're setting various dimensions on the dialog. We are pulling primitives out, which are related to that dialog. It looks like basically building the text out. It does seem like a lot of pulling out primitives from various locations. So let's assume that that is the case. I want to look at one more thing here. So here we're pulling out a string related to what character is speaking. So we're probably gonna have something similar to that. Yeah, let's go back and see if we can use that information to our advantage. I am going to rename arg0 self. And I do want to get going, however, I don't want to spend too much time on these unknowns at the moment. These do look like they are all consecutive. And likely are part of the same structure. Let's look at this one here. Oh, this is, yeah, this is... pulling in several of these offsets, which I had assumed were pointers to primitives. Let's see, how do we get started here? I don't think we're going to be able to use the decompiler right away. Maybe I'll look at these one more time. I would like as many of these to be resolved by the decompiler as possible, but I don't know if I'm going to be able to start off with that. When we can get type information early, a lot of the work can be done for us. So I might start with that, though. I might... here we have... it does appear collections of bytes. So we'll start with that, and it might be wrong, but it might get us closer. It is possible that this is a... that this is a 32-bit value as well. Which would be, oops. I'm going to look at where this is being used one more time. No, so this is, yeah, this is part of a larger struct. So let's assume that this is an array of, we'll assume it's an array of bytes, and then we'll move on from there. So we can start pulling these into the context and leave the ones that are unknown. Sorry, I'm flip-flopping. These others may or may not be offsets into, so like this 5D8 may be a collection of bytes, it may be a 32-bit value. The next offset 5DC does appear to be shorts. These may change, but I'm just going to go based on what I see right now. It's not clear whether 5E4, based on that data listing, whether that is a 32-bit value or something else. It's being cast as a 32-bit value, so let's assume that it is. And again, it's going to be an array. So I'm basing, and this is one way to try to determine what the data types are. You can see what the decompiler cast says, but you can also look at the scale here. So we have some index that we're adding to the pointer to that particular memory location, and whatever that index is being scaled by 2 bytes, which means it's a 16-bit value. That's kind of a good way to start. Whereas this one is taking a reference to this. And it's less, so it's it's shifting to the left by 16 bits, but then shifting back right by 16 bits. And ultimately casting as a 16-bit. So I'm going to assume that's 16-bit as well. We'll see. What I'd like to do initially, especially when I don't know necessarily what I'm getting into, is just get things compiling and then work it out from there. So here we have a 32-bit value, and we're pulling that from this particular memory location. This looks like it probably isn't a reference. It is just a 32-bit value. I'm going to look at that as well. So these are 32-bit values. I mean, maybe not. Maybe they're, maybe it's an array of bytes. I want to look at this cutscene unknown 2. And see if that 32-bit makes sense. So in other uses, it's grabbing a just that the value at that memory location. But that, oh, that's odd. So my declaration is wrong. I don't know if that one was created by the decompiler or not. No, it doesn't look like it. I see. Mine. Oh, that's curious. So this is also implemented in the stage selection screen, but the signature is different. This is being used as a 32-bit value, and a pointer to anything is going to be a 32-bit value on MIPS. But this really looks to me like it's a pointer and not a 32, just a signed 32-bit value. I want to see this. There may be something here that I'm not familiar with. No, this is a pointer. I'm not sure why the signature is assigned 32. That seems wrong to me, as opposed to a char pointer. Char? Do people say char? I say char. If you say char, I'm sorry, you're wrong. So let's change that, and that then tells us what that other value is. That's right. It is char, like charred. Charmander. You don't say Caremander. Oh, what? All right, so this last one is still odd. So it's this is a collection of pointers. So remembering what was happening in this Entity Maria cutscene for NZ0, there are several cases where primitives are being pulled from the dialogue, and my guess is that that's what this is that we don't have this symbol mapped yet. Sorry. We don't. Let me check on that to see if that symbol is mapped. It is. This really does look like a very similar structure to that. I'm going to treat this as a primitive array for now. And if it turns out to not be, then we can change it. So I'm going to copy that into the context, and hopefully we'll get a decompile with more fields in place. Not everything. Looks like many of those still didn't map. So we'll start working top to bottom and get rid of as many of the compiler errors and warnings. We have a lot of them. That's okay. We'll figure it out. So we need to know what this var S13 is. So this one certainly is a primitive. We're pulling a index from the primitive buffer. So we need to slowly go through. In cases like this where there's a bunch of errors and warnings, many of my roommates in college were mechanical engineers, but they were forced to take a relatively basic computer programming course. And one of them liked to say that if his code wasn't compiling, he just commented things out until it compiled. And that's maybe what we're going to do here. This is a lot of noise. We have a lot of offsets that are certainly incorrect because the types are wrong. And we have a very long function. So it may be better to ignore many of those errors for now and work kind of top down. I am going to look to see if I can get something that's compiling. That I prefer to work that way as opposed to going blind for too long. And so if I can get something that's compiling, I will prefer that over something that's not. So here we're incrementing a pointer So we need, my assumption was that this was going to be a primitive. And so we don't have, the decompiler wasn't willing to make that inference. And that might be legitimate. It might not be. So let's look at some of the offsets before we go into look at some of those structures and test that hypothesis. So we have something looking at unknown 0, unknown 2C, 1A, E, 24, 30. So if it's a primitive, we don't want to go over hex 30 to 32. I don't remember what the last field is, but a primitive is hex 34 bytes in size. And this does stay within that bounds. So I'm going to look at that. That's going to be in the primitive header. Yeah, and our last field is at offset 32 for the PlayStation. I'm starting with the PlayStation here. I actually may be better off starting with the PSP in this case, because the decompiler is not giving us much besides the structure here. But this does look like a primitive. So temp S1. We'll call it a primitive, and now we have to go patch up all these offsets that are wrong. And let me look at the first. So yeah, our offset 0 is the next primitive. What's interesting for temp S1, one of the first things we were doing was incrementing that. Yeah, that is, so Roaming pointed out another C quirk is not returning a value. We see that a lot in the weapon functions especially. Their signature says that they're going to return a 32-bit value, and then they don't return anything, and the compiler doesn't complain. And so there are some side effects to that in the assembly that's going to be generated. The caller is going to avoid using the V0 register, because that's where the return value is going to be stored. But also, the code in that function might avoid using the V0 register because that's going to be used as a return value. The caller is going to expect a return value in that field, and so it wants to make sure that it's not setting that to anything other than 0. Okay, so let's go through this slowly and painfully. So this is going to be next, and temp v1 is going to be the next primitive. So we need to make sure that that is a primitive as well. Early C was definitely fast and loose. So we probably can write that like this. I don't know if we'll have to see if that's reasonable. And then we're looking at the next. However, then that value is being masked. which doesn't make sense. Let me back up. I'm also going to look at entity. So it's not a primitive, it must be an entity. The 0 there is probably fine. Let's go look at this other one. This is going to turn out to be probably not the best function to decompile live, but sometimes that happens. You get into a function that you don't really understand the structure of, and it takes a little while to reason about. I do think I am going to, there are going to be some easier things to fix in this. Like these go-tos. So let's just get rid of a bunch of the things that we don't have yet, and work on the things that we do have. So I'm going to just get rid of all of this. I dislike that the decompiler puts in these block comments because it makes it more difficult for me to get rid of all of this. So really what I want to do is break down the problem into smaller problems so that we don't have to tackle the entire thing at once and we can make a little progress. And then expand from there. We definitely have a lot of control statements that, like loops implemented as go-tos, which will need to be fixed. I should just write a regular expression for this, and I think I will. Just checking to see what I have. What have I done? All right, so we have a very low match, but we are compiling. So obviously we're going to be missing everything in the middle, and that's fine. I'm not. We'll pull in each of these as necessary. One of the first things I want to do is get rid of this this block here. This is pretty common in a lot of these switches where we have cases where something simple like a return is shared as common code between a bunch of things. I'm going to invert this. Maybe it doesn't need to be inverted. But I am going to basically just get rid of this block. So we need to find all the other go-tos that are going to that. And in each of those cases, what we're going to be doing is destroying the entity and then returning. This one down here is a relatively common pattern where we're trying to allocate a primitive, and if that primitive allocation fails, then we're going to destroy the entity and return. This case 5 looks like a relatively straightforward primitive manipulation case, so I'm going to pull that one out. And we can work on that a little as well. We have another one where we're setting the secondary step, or incrementing the secondary step. I'll stick with block 136, which is just going to destroy the entity. So that's really simple and easy to get rid of. And we can get rid of this now as well. The default case for this outer switch is going to return. It's going to do that anyway because there's nothing after that code, so we can get rid of that. What I'm not sure of, and we can look at the assembly here, but it's going to be in kind of an odd state with all this code commented out. Is this check inverted or not? Let's go down and see. Yeah, it's just a mess right now, so it's probably not worth fretting about that yet. This may be saying if there's a playable character, then destroy the entity and return. In that case, we can lose one level of nesting. It's not terribly important to do that at the moment, though. So we did have one other block that was incrementing this. So let's find all these block 115s, and those are going to kind of be the same thing where they're just incrementing the step and then returning. And in some cases, we don't need to add the explicit return because the control flow will do that for us. And there's only one of those as well. The GCC optimizer is a little crazy sometimes. Yeah, C being ASM++ is, I mean, it certainly is nicer. And the pictures that I showed earlier kind of illustrate how like 30 plus lines of assembly translate into like 5 lines of C. I'd much rather write 5 lines of C. And again, you know, I came from a time when C was considered a, a high-level language compared to assembly. Nothing like we have today. If there's anything that people want to know about, hear about, or talk about along the way, definitely feel free to comment, and I'll try to address any of those along the way. Fortunately, or unfortunately, I don't know, KNRC was already old by the time I was learning C. We could actually allocate some of the style here in GCC2 where you have to pre-declare all of your variables up in the header. There are some cases where within blocks you can declare variables as well, but not scoping a variable to like a for loop, for example, that's kind of wild to me. So let's look at what some of these errors are that we have. Okay, so I pulled this one out. So we do need this to be primitive index. Yeah, to me, modern C is a very nice language. I don't have any issues with it. Personal preference. C++, after I left the C++ world, that was like something you could never go back to. That is just such a terse language. I have written C++ professionally, and I wouldn't feel comfortable with it now. I spent some time hacking on Chiaki, which is a open source remote play client for PlayStation, and that's all in C++. And I had done Qt stuff, Qt, a while ago, and most of that's still the same as like 20 years ago. So I was able to follow that relatively well. There's not like a ton of any of the super modern C++ stuff there. So we do have this primitive here, and we're going to have to go through and figure out all these fields. And so off on the side, I do have the primitive fields listed and their offsets. It is in the primitive.h file. I did forget to put my scratch in there if you want to follow along there. So I'm not going to show that on screen, but I'm going to go through and fix up these fields here. So when we see cases like this, where R0 is being set after R1, those are typically written in line. And we're probably going to see something very similar for the rest of these. I made the mistake last week of saying RBG instead of RGB. RBG, of course, being Ruth Bader Ginsburg for all the Americans. RGB, very different. It's nice when the compiler does this for you, but not insurmountable. Or the decompiler, I should say. That's right. Whenever I'm programming graphics, I'm always thinking of the Supreme Court. Aren't you? I've been meaning to look at these priority values. The priority values seem somewhat arbitrary, but my guess is that there are different, like basically they're enumerations for what plane these should be on. So let's see, unknown 16 is Y1. So we're getting our Y offset from this field here. Unknown A is probably going to be Y0. Yes, it is. And then this temporary variable is unnecessary. Our var A in this case is just our incrementing variable. So it's probably worth replacing that at some point. So we're looking back 28 bytes from this symbol that we have. This was mentioned, I think, yesterday or the day before in chat. Can structs or will the compiler put negative offsets in place? Maybe it was in Discord, I can't remember where, but yes, certainly. And this is one of those cases where there is a negative offset to this particular address. It does that because to load a 32-bit address in MIPS requires 2 instructions because immediate values can only be 16 bits at most. And so if it has this address in a register already, the compiler will say a subtraction on that address is cheaper than reloading a new address. Oh yeah, thank you, Roaming. It was you. And so it will do that. There are some issues then that you run into on decomp.me that may or may not work out because this symbol is known and this is the symbol that's used in the assembly. When you compile this, you may or may not get a matching symbol plus constant value. I can't remember if I loaded this or not, but I'm going to load it again because I've forgotten what it is. Oh, it's SPSS. So this is all uninitialized data, so you don't really get a lot of information from this. We might be able to see a little bit about the structure, but no, not much. Let me... see what -28 is. So it's 1AE 7C. So there is a label on that value. So we're loading that value, and then we're loading Y as well. So that is, we should just be able to use this directly, and I'm going to declare this up here. This may not work out, but we'll see. Where was I? And we can get rid of this temp. So unknown 2C. Oops. Did I switch back? Yes, I did. Unknown 2C is X3. I mentioned this before, but just to reiterate, that's odd that these are out of order. They might not be, but we'll see about that as well. So now we have this kind of funny, shift, and the decompiler put all this in, but what's happening is that this particular, the type of this particular value is 16-bit value. Var A0 is a 32-bit value, and so when you have a register that's being used as a 32-bit value and you want the 16 bits, this is little endian. We need to take the smaller bits that are in there. So the shift is just basically converting between the width of those variables, and then we're shifting back by 1 less than we shifted to the left, and that's because it's multiplied by 2, because each of these entries is 2 bytes. And that is already a 16-bit. So we'd write it more typically like that. And so this is next. So this should be close to compiling. We might not have a prim isn't defined yet correctly. Decomp.me is going a little slow. So just a few more things to work out to get this part to compile. We'll change that to an increment. 481. Incompatible types. So let's see what var a0 is defined as. I might just call this I here, because we'll want that to be I initially anyway. This probably should be rewritten as probably a for loop. It can really quickly be written as a while loop with what's there. Whether it's a for loop or not, we'll have to see. That went away. And then I need my I. My I. So the do we use little endian macros? So far, none of this code would be affected by endianness that I've seen. Is that true? That might not be quite right. There are definitely places where arrays of like 16-bit values are cast in all kinds of different ways, and so MIPS for PSP and PlayStation are both little endian. There is some utilities that bring in this code that are compiling on the PC, but I've not tried compiling that on ARM. It's only, as far as I know, it's only being compiled on x86, which is also little endian, and so those things will just work. If you're loading some of the assets from disk, would that have endianness? The way that it's loaded is basically you give an offset to a location on the disk, and then a memory location and a size, and then basically all of that's streamed in order. So you don't have to worry necessarily about the endianness of what's on disk. Well, I should say you don't have to worry about it in the case of this particular game, which is storing things in the order that it expects. To make it portable to like ARM, for example, that would be interesting. So we do have the PowerPC version for Xbox 360, and PowerPC is big endian. So we will have to look, I guess, if that is an issue. There hasn't been any work done on that port yet, besides just dumping the Ghidra listing. No, the Xbox is not emulated, which is awesome. So the Xbox is the PlayStation version of the game recompiled for PowerPC. And I believe it's compiled, so Xbox 360 was PowerPC 64. If I remember correctly, the game is actually compiled for 32-bit PowerPC. which is really nice. So we know that there's a working Big Endian version of the game. Hey, Nate the Great, good to see you. So Decomp is going well. I mentioned earlier in the stream that we have this Maria cutscene overlay that we're working on, and about 95% of it was duplicated code, and so we could just bring in code that we've already had. I was looking at, I don't know if any of you are working on other decomps. I was looking at CodeDog, spelled Cod Dog, which is used to find dupes. We have a dupe tool that Sozu wrote, which compares assembly implementations and basically does the cross product of comparisons of all the assembly methods to find duplicates. And CodeDog looks at compiled ELF binaries and tries to find duplicates there. One of the issues with looking at the ELF binaries is you have to have a lot of the infrastructure in place to be compiling new ELF binaries, which is, there's startup cost as opposed to just having splat config, which is extracting. Oh, I'm missing a brace somewhere. But looking at the binary directly is interesting as well. Where did I miss my parentheses? Oh, we have an inner switch here. Nested switches. So one more incompatible type, and we should have something that's close to compiling here again. We need to take the reference. If you are interested, so Blue Harvey saying he's not acquainted with decomps. Don't mean to call you out. You said it, not me. Just want to repeat for people who can't necessarily read the small text. Wants to know where to start. 2 days ago, and now it should be uploaded to YouTube today. I went through setting up a new workspace for the SOTN Decomp project specifically. I found I hadn't done decompilations prior to this project. I had looked at a lot of not PowerPC, 68K assembly, primarily to generate code listings and write a very bare bones emulator. So I'd spent a lot of time in the assembly there, but not necessarily decompiling back to C. I found the way that this project was structured and the tooling around this project just happened to hit a lot of the things that I was familiar with. Plus, I enjoy the game quite a bit. I could get started pretty quickly on this one. So for me, it was a good place to start. So what is this complaining about? I'm taking a reference to a primitive. Do I... So if you know C, if you're familiar with... Oh, it just needed to recompile. If you're familiar with assembly at all, MIPS assembly is probably one of the more straightforward assembly languages that you could find. most of my time I spent in the Motorola family of languages, and so I kind of have a preference there. Fortunately, it's not x86 or something else that's overly complicated. So we do have this case statement decompiled. Unfortunately, because this is so far into the switch, we're not going to get matches here yet. I'm probably going to end here for today, and we can keep working on this little by little over the next couple days. What decomp.me is going to do is, as best as possible, compare the C code or the compiled assembly that this C code is generating with the target assembly. And I'm not sure what I haven't looked at what diff algorithm it's using, but in cases like this, we definitely do not have these instructions. They're commented out, but it's going to eagerly kind of move up some of the instructions we have, and so these matches along the way here are not very accurate, and so we'd have to work at some of these earlier cases to kind of get a very accurate compilation here. So I might spend some time offline looking at these arrays and getting the types of those correct. And then, oh, thank you. So yeah, they call this a diff algorithm, but the Levenshtein distance is, or Levenshtein distance is how many edits are necessary. Not necessarily how you might align these lines with one another. I guess maybe they're close enough because this is where it would put the edits in place. Things like the diff utility and Git's internal diff, for example, aren't necessarily. I guess they would be using some form of edit distance as a heuristic. I usually think of Levenshtein, though, as a numeric value as opposed to where the edits are taking place. So we'll come back to this tomorrow. It'll take a little while. Nothing in here is overly complex. It's just types that are missing that made this one a little more difficult today. None of the what I find most difficult when doing the decomps is when it gets into some of the relatively heavy graphical operations. I've found that part of programming to be among the most difficult and most math heavy, and so usually I take longer to do those. Oh, Roman, you got weapon 17 at 99%. That is awesome. I will look at that weapon. I don't mind. Yeah, trying to see. Let's load up your scratch. Super excited about that. Were you editing the PSP version or the PlayStation version? Hey, Nate the Great. I was looking at the PlayStation version of the Entity Maria cutscene for the Clock Room cutscene. So let's see what we got. So we have some register swaps. I might jump over to the PSP version. There are some wacky things on the GCC side. Let me go through and see if any of those stand out. I ran into something yesterday where the less than equals. Let's look at the PSP side. Yeah, the PSP side might have more issues. However, often those are easier issues to resolve, and typically. They're more straightforward. So here we have register swap here, line 80. So I'm not going to worry about that because that's a constant. I want to find some other S registers that are not constants. Some of those we might be able to resolve. So here, for example, is S4 versus S5. We may be able to, coerce that. Before I do that, though, I'm going to see if there's any instruction differences here. So we have a move on line 72. The set weapons property, most likely, this is being stored in a variable, and that variable is never being used. But the MetroWorks compiler will generate an instruction for that move regardless. Let's look at the signature for that. Oh, it's a void return though. Gross. If we didn't have the signature, we wouldn't know that. So let's pretend that we don't. Let's see if we can force that move. Oh, I'm reading this backwards. We have a move that we don't want. That's more difficult. So I'm going to skip that. Another move that we don't want on line 95. Roaming, have you used the permuter? Let's try that. Let's throw it into the permuter then, and see what we can see. I found that the permuter is not necessarily very straightforward to use, and so I have a stored command that I use regularly. This one was just renamed. Okay, so we are failing, which is fine. Hey, look at that. I have an entity weapon attack as the... Oh, drat. I changed my... I mentioned this on Monday. Python is now stored in a virtual environment in the project. What do I want to do on a source? Activate. And so I need to install toml. All right, there we go. So I'll let the permuter run on that for a while and see if it finds anything. Super awesome that that you were able to get that far, though. I will, if this finds anything, I'll fork it, and then are you in the Discord? All right, I'll poke you in the Discord if this comes back with anything. Hey, Project Omega, good to have you back. I haven't looked at... Tomorrow's Thursday. Maybe I'll look at Arbitrary Code Glitch tonight and see if I can find any foundations in the code that we have decompiled to figure out what might be going on. So there's... yeah, I'll take a look at it and see what some of the details are. That's super interesting. Looking at this, so at the beginning of the stream, I talked about computer organization and design, which is the MIPS book written by one of the MIPS founders. And it's written from the perspective of writing MIPS, writing code for MIPS in Unix-like environments. And so it talks about all the things that you normally think of with programming in C, so building objects, linking them against libraries, building executables or libraries, things like that. It doesn't talk about embedded systems like this, where all memory is writable by anybody at any time, and instead of linking a library that's brought in by the operating system, we're just telling the BIOS, hey, go stream all this data from a disk to, oh, it looks like the permuter might have found it. Go stream all this data from the disk to this location in memory. Oh, by the way, anything can write to that location in memory, including the game if you find a glitch. Let's see what we found. Is it a good one? It's pretty good. Maybe. No. No, it's not good. Never mind. Let's do it though and see what it looks like in the editor. So we're looking for the decrement. I think it's this one here. Oh, one interesting thing that I didn't see is this is unnecessary. This return. Let's find where this is happening. So we don't need this return. I don't think that's going to change anything else. Oh, it did. We do need the return. Of course we need the return. How could we? How could we do anything without the return? So the permuter said if I assign I here, everything will be swell. Oops, I meant to hit compile. And the compiler says, no, no, no. Let me get back to the beginning. Too many parentheses, I think. So that is a gross hack. And it also doesn't completely clear up all the register issues. So close, 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 but probably not what we're looking for. I do wonder if sometimes I'll pull random things out like that. The rest of this would just be me poking around, so I'm not going to continue that on the stream. But it is awesome that it is this close, and hopefully, yeah, we can get rid of that other one. My guess is that Biz Murphy would look at this and in 2 seconds know exactly what was going on. Very cool. Thank you, Roaming. That's awesome. Yeah, I'll watch that video tonight, Nate the Great, and see if there's anything interesting. It would be super cool if we can find where in code that is. I do think it would be if we can find where that is in code. I have a hypothesis about why it only works on the original PlayStation version, and it has to do with GCC optimization. But we'll get back to that, and yeah, maybe we'll find something cool with that. That's all I have for today. If you want to know more about the Symphony of the Night decompilation project, go to sotin.z.dev. Join us in Discord, and if you're interested in decompiling, now we have streams where we're setting up a new workspace with this project, and we've been going over a bunch of different things. If there's interest in me kind of editing down a series about different topics in this, I could spend some time doing that as well. If you enjoyed what you see and you're here for the first time, please follow on Twitch. If you want to see old episodes, Twitch has the last couple weeks, maybe 2 weeks. Otherwise, YouTube, Made Up of Wires there. I've been uploading old ones there with terrible audio, now hopefully better audio. Thanks for the suggestion on YouTube to fix my sound. It made me stop and listen to what I was doing. And if you have any comments, questions, suggestions, whatever, definitely pop into a live stream and chat. It's one of the best parts, I think. It's totally fun. I love being able to go over and kind of do this and hopefully educate people about what we're doing here on the Decomp project, but also decompilation in general. But even better to me is getting that live feedback and interacting with people along the way. So stop by Twitch if you're watching this on YouTube. I'm here 4 days a week. That's all I got for you. Yeah, let's. Roaming pointed out we have a new match over here. Let's check that out and see if there's anything good. There was a question on YouTube. They mentioned something about enjoying the decompilation content, but they were stuck on what window manager and desktop environment I was using. All the stuff I do is actually just on a Mac, and I'm SSH'd into a Linux box. So I I hate to disappoint people, but I am just using I'm using the superior operating system. I'll say it. All right, back to what is our match? We actually got 2 of them. So we're saving this off into a separate variable and running this out of order. I mean, yeah, it might fix some of the registers, but I don't like it. I don't think that's, unfortunately, that's not something that's going to help. There may or may not be something here. Pulling that out into a separate variable, but again, it's pretty unlikely. So unfortunately, I think those are going to be misses as well. Sorry about that. I'll let it run though for a couple hours, and we'll see what I can find. All right, that's all I got for you. Have a great day, and we'll be back tomorrow. And yeah, if I can find content about the code glitch, let's dig into that. Bye.